Now I'm going to go ahead and go over how to graph piecewise functions. Okay, there are many different methods you can choose to graph. I like to make little helpful guides. What I do when I graph a piecewise function is I very lightly with my pencil, this is actually part of the graph, I indicate where each section is going to be. So this one says x is less than -3, so I'm going to go to -3 on the x-axis, put a light dotted line. In fact, that's way too heavy, so I'm going to make it even lighter so you can barely see it. There it is. Okay, well, that tells me that x plus 1 needs to be in this little section. It needs to be less than -3. So we'll be graphing x plus 1 over here. The next one, 3, is between -3 and 0. So I have the -3 already indicated. Let's go to 0. Oh, I didn't change it for all of them correctly. So, so here's 0. So that means our graph 3 will be in this section. And then last but not least, we're going to go ahead and do our last one. It goes from 0, so we already have 0 all the way till 4. That's the section right here. And in this section, we need to be graphing the absolute value of x minus 3. Okay, so I like to know where everything is. From there, I actually do most of this in my head. It's not too hard for most problems. What I do is I actually just make a quick table, and wherever I see any of my dotted lines, I'm going to make sure I first plug that in. So for instance, -3 is one of my dotted lines in this region. Well, -3 plus 1, if I put it in for x, is -2. So I'm going to go to -3, I'm going to go to -2. Only thing I need to watch out for is the sign of my original problem. It does not include -3, so I put an open circle right here. And then from there, I know that this is a line because there's no exponent on the x. It's in the form y equals mx plus b. Lines, you only need 2 points, so I might, in my head, pick another point in this region. So with -4, -4 plus 1 is -3. It's right here. And then I'd go ahead and draw my line. Okay, then I go to my next one. 3 is actually even easier. 3 is a horizontal line, like so, and it's just on 3. So for 3, I just have to make sure that I have the right, that I make sure I have open circles in the right place and closed circles in the right places. So it's only on the dotted lines I have to worry about an open or closed circle. So if I go to -3, since it's equal to, I'm going to have a closed circle on that dotted line. For 0, it's not equal to, that's this dotted line. So I'm going to make sure I have an open circle. And I go straight across. Okay, last but not least, I'm going to go to this section. I have x minus 3. Now this is an absolute value graph, and if you remember our parent functions, we're shifting over to the right 3. So right here, shifting right 3. So I have my vertex right there. And then other than that, I'm not doing anything to my coordinates. So I'd have +1 or -1, up 1, right 1, up 1, so on. However, I need to extend it until I get to each end. So notice on 4, it was equal to, so I make a closed circle. But I want to know what our value is going to be at 0 of this dotted line. So I can make a table if I want. If I plug 0 in, you get the absolute value of 0 minus 3, plus the absolute value of -3, which is just +3. Now it's also open circle, so they're both going to be open, and then I can go ahead and just extend the rest of my line. Or you could just remember that absolute values always have the same slope on either side, so you could just keep going up by 1, or left 1, up 1, left 1, up 1, until you get there. That would be my piecewise graph.